Hi guys, I want to do now a solution for the second part of our 8.2 where we looked at still homogeneous but of arbitrary degree. And so here the first example was number 18, and that was this recurrence relation. So we see that this has degree 3. Again, where do we get the degree? How far do we have to go back? In other words, what's the lowest or the most that we have to subtract from the index n here? That is 3. Okay, and that's why this is recurrence relation degree 3. It recurs. It uses recursion on the last 3 before. Okay, that's degree 3. That's good to know, because we know now that the characteristic equation, so step 1, the characteristic equation will have degree 3. And how do we get these? Well, we know what we have to do is replace this an as we go down by lower powers of r. And the highest power of r, of course, is the third power. We need to know where to start. So this is r cubed. This will become r cubed. And then we have 6an minus 1, that becomes 6r squared. The next power is r, so minus 12r. And then the last power is, of course, the zeroth power, which we don't write, that is 8. Make sure that you understand how to get these characteristic equations and do it the right way. And always be on the lookout for if they try to trick you by putting these AIs in a different order or something like that. Always be careful, right? It should be ordered always from in descending powers or descending indices. Okay, that's the characteristic equation which we now solve, but to do that we're gonna bring everything to one and the same side. And the only way that we can solve this is we look for divisors of 8, minus 8, and there's quite a lot. There's plus minus 1, there's plus minus 2, there's plus minus 4, and there's plus minus 8. But still, it's not too many things to try, and you should always try the first ones. 1. Does 1 work? 1 minus 6 plus 12 minus 8, minus 1. Okay, but the minus 1, with minus signs, you have to be careful, right? Odd powers will be negative, even powers will be positive. But if you do this, you get minus 1, minus 6, minus 12, minus 8. Nope. 2. Okay, let's do what 2 is. Then we get an 8 minus 24 plus 24 minus 8, and that is 0. So we see that r is 2, works. So r is 1, nope. R is negative 1, nope. But r is 2, it works. You see, sometimes you have to try a little bit more. It's not always the very first one that you try that works. Okay, this means what? This means that we can factor out, remember, if you have a root, that means that you can factor out a linear term r minus that root, so r minus 2 here, and then what's left here will be of degree 1 less, so quadratic. Now what is that? We do long division. R cubed minus 6r squared plus 12r minus 8. We have we divide here by r minus 2. And how the long division works, how many times does r go in r cubed? R squared times. You always compare the highest degree terms with the highest degree terms. All the lower terms do not play in choosing this r squared. Okay, then you multiply. The next thing you do is, right, you r squared multiply this with this guy, so that would be r squared times r, that's r cubed, minus 2r squared, and then you subtract. So subtracting means you change the signs and then add, or you can do subtract if you're good at subtraction. That is 0 here, and that is minus 4r squared there. And we repeat the process. Now the highest degree is this, so how many times does r go in there? Minus 4r times. Okay. So minus 4r squared. Again, we multiply minus 4r. I'm going to multiply this by that. That gives me minus 4r squared plus 8r. Be very careful with all the signs that we get this way, right? Because if you get this wrong, then yeah. So this becomes a plus, and this now becomes a minus. And we add. That has to become 0 to make the wrong choice. 12r minus 8r is 4r. And then we have a minus 8 still, but that's not important because how many times does r go in 4r? 4 times. times plus 4. So we get 4r minus 8, and we subtract again. Now you see that it's the same thing, so everything is going to cancel, and that's what should happen, right? This is 0, but this also has to be 0 because at the end of the calculation, we should have a remainder 0. Okay, so we know that this now factors as 1. It's the quadratic that we get here is exactly the outcome of our division. Good. Now we can factor that one, so we need two numbers that multiply to 4 and add up to -4, or you can see that this is actually a double product formula, and so we have r minus 2, r minus 2, r minus 2, but we want to combine these so that we know what the multiplicities are, and this turns out that there's only one root, but in multiplicity 3. So r is 2 with multiplicity 3. Now that is important in our next step because we're gonna say we're gonna propose a form of our, we're gonna describe the general homogeneous solution. That's something we talked about today in the lecture. So how does it look like? Well, for every root, there's only one, we take that as the base of an exponential function, 2 to the n, that's the geometric series, the geometric sequence part. And then this multiplicity 3, what does that mean? That means that we're going to plug in here a polynomial of 1 degree less, so a quadratic polynomial. Which quadratic polynomial? Well, we don't know, so we have to make it with general coefficients. And it's a polynomial in n. Okay, perhaps I should have stressed this one sometimes. Some people might write x here, but the variable here is n. The variable, if you want, it's not a variable in the sense of calculus, it's an index really, it's a counter, but it's the n. Okay, so this has to be a polynomial in degree 2, one less than the multiplicity, and it has to be with general coefficients. Now you might say, don't we normally write this as an squared plus bn plus c? No, okay. The choice of the what you call these variables, if you don't like Greek letters, use other letters, but make sure you use letters that are not used elsewhere. Okay. So this is the general homogeneous solution. But we know that there is a very specific one because we have initial conditions, and these initial conditions were -5, -9, and 15. So A0 was -5, A1 was -9, and A2 was, okay, what was it now? -5, -9, and 15. Okay. So how do we get this? Well, in this equation, if you want, I'll do it a little bit on the table, a little bit like this. Okay, let me make the table here. So we put here alpha plus beta n plus gamma n square, and here n is 0. What's the result? Well, alpha. If n is 1, then the result is alpha plus, oh, sorry, I forgot there's a 2 to the power n here. Okay, then I have alpha plus beta plus gamma to the 2 to the power 1 times 2. And then finally, n is 2. I get alpha plus 2 beta plus 4 gamma times 2 squared times 4. And the values are -5, -9, and 15. And now we have to, so we have to think of this here as a system, a linear system of equations, 3 unknowns with 3 equations. But we are very lucky in this case because we already know what alpha is. Alpha is -5. So we can use that. So to write out this, let's write out, so this one will tell you alpha is -5. I'll write out the other one a little bit because it still is multiplication. There's a 2 alpha plus 2 beta plus 2 gamma is -9. But I know that 2 alpha is -5. So there is -10 plus 2 beta plus 2 gamma is -9. Bring up -9. Bring the -10 to the other side. So +10 plus 10. So get 2 beta plus 2 gamma is 1. Okay, that's that guy. And then the other one is we have, so this is this equation, right? Now this equation is 4 alpha plus 8 beta plus 16 gamma equals 15. So alpha was, so this is alpha -5, so that is -20 plus 8 beta plus 16 gamma is 15. So bring this to the other side. That means 8 beta plus 16 gamma is 35. And now we have to do either elimination or something like that. I like elimination here. What I'm going to do is I'm going to multiply this times 4 and subtract from this. So actually, perhaps the better way to formulate it is, let me write it, I'll do it in a different color here. I'm going to multiply this with negative 4 and then add. Because this would then be minus 8 beta minus 8 gamma equals negative 4. And if I add this to that, I get, well, the betas cancel, that's the whole point. And then I have 16 gamma minus 8 gamma, so 8 gamma equals 35 minus 4, that is 31. So gamma is 31 over 8. Yeah, it's a, I guess, let me double check here. I said I normally don't have fractions, but yeah, that's me. That's the textbook sometimes is a little bit naughtier. And so this was question number 18. Just double checking that I did not make any mistakes somewhere in there down there. Oh, 18 is no, that we don't know yet. So no, I'm pretty sure this is correct. And then once I have this, I can plug this in any of these. I can plug it in here. So I get 2 beta is twice, so that's 62 plus 2 beta plus 62 over 8. That's the gamma, right? Equals 1. So that means 2 beta equals 1 minus 62 eighths. Well, 62 eighths, I can actually simplify this as 31 over 4. Sorry, let me write this top part better. What am I doing here? No, 31 plus 4. Okay. Minus 31 over 4. So that is, if you want 4 minus 31 over 4, that is minus 27 over 4. And that's 2 beta, so beta is minus 27 over 8. So what we conclude is that our solution is, always try to make the conclusion, write down what the final answer is, right? Minus 5 minus 27 over 8n plus 31 over 8n square times 2 to the power n. It's a little bit annoying, but we could double check that we didn't do anything wrong here by, like for instance, do I get the initial condition if I plug in n equals 1? Just double checking, minus 5 minus 27 over 8 plus 31 over 8. So these two cancel and become 4 over 8, which is a half. Okay, and I have to multiply this whole thing with 2 to the power 1. So I get minus 10, this was plus, minus, so this is minus 10. This was a half, and so that's plus 1, so minus 9, and that's exactly the initial condition, right? Yeah. Okay. So that is an example of how you solve one, but I also wanted to do the other thing that is extra, and therefore I gave this extra problem set, homework problem set, just so that I hope it helps you understand better where the relation between a characteristic equation and this recurrence relation. So there, in the additional question number 3, I had a solution and I said this is the sequence, that I want to study, and I know that this sequence satisfies it satisfies a linear, homogeneous recurrence relation with constant coefficients of degree, and I told you what the degree was, but we can actually figure it out ourselves. What is the degree here? Well, I said the degree 4. Let me say degree 4 here. I gave that, but let me now show you that you can figure it out. Why? Well, how do you get to the characteristic equation? It comes down to actually the same thing. So that we need to build the characteristic equation. Once we have that, we will be able to write down the actual recurrence relation. So the characteristic equation, what do we need? We need to know what the roots are, and we need to know what their multiplicity is. Okay, so what are the roots here? The roots, how do we read off the roots? These are the basis of the geometric sequences that occur in this general linear homogeneous equation. And so we see one is clear, the most obvious one is the 3 here. So let's write that one. The root is 3. And what is the multiplicity? Now, what is the multiplicity is the degree of the polynomial that comes in front of it plus 1, because remember, in the other way around, you subtract 1, right? So if you have multiplicity 3, then you put a polynomial of degree 2. So in other words, if you have a polynomial of degree 2, that degree 1, that means it comes from a multiplicity 2. So the multiplicity is 2 here. Now, all in total, so what we always need to have is that the sum of the multiplicities should be equal to the degree, right? That's because that's how you factor your characteristic equations. Here you see it's factored, it has only one root. Very often you have a root of multiplicity 2 and a root of multiplicity 1, that would be then 2 plus 1, degree 3. So the sum of the multiplicities is equal to the degree. So it seems like we're clearly missing some roots here still. Why is that? Because there is something that we don't really see, that is there is a 1 to the power n. I'll write it in the orange here, 1 to the power n. We don't write that, but it is there, and this tells us that actually r is 1 is a root. Now what's the degree, or rather the multiplicity? Well, we have to look at the degree of this guy. Don't say, oh, there is one guy there, so that's it. No. This has degree 1, and therefore the multiplicity will be 1 more, so 2. And now we see that the sum, this adds up to 4. That has to be the degree. Okay, if I do even longer things, bit more degrees, then you should have more roots and so on. Okay, so that's that. What does this now mean? We can now write down the characteristic equation because we know exactly what it looks like. The characteristic equation is r minus 3 to the power 2, r minus 1 to the power 2. These are the powers and these are the roots. So this is our characteristic equation, and now the only thing I have to do is actually factor this out. You can do this by hand. I showed you that, especially for homework problems, you can do this also with using an online program like Wolfram Alpha here, and Wolfram Alpha. And so let's put it in. We had with iPad it's kind of annoying to do this. X minus, what was it? 3, right? X minus 3 to the power 2. X minus 1 to the power 2. Okay. I hope that he doesn't complain about the x's being different. Okay, no. That's the problem is he makes a difference between capital X's and non-capital X's. That's annoying, but okay. So it is, no, why is he keeps trying to write here a cap? No, I don't want a cap guy. No. Jesus. Okay, let me write, he keeps writing X. Okay, X. No. I don't know why iPad sometimes does these weird things that it feels like it should do things in caps. There's a parenthesis, so why would there be a cap? Okay, so now I got it. Okay, so it's, wait a little bit, here it tells me, okay, here we have it. I'm going to write it down. X to the 4th. We're looking here, I can, yeah, right, I can copy this, right, step by step. So, no, how did we do this? Okay, plain text, and then copy this thing. Okay, I didn't want you to do this, but select all. Copy. Let's paste it into my thingy here. So this is equal to. How do we paste here? I guess I have to do it this way. Paste, where's my pen here? Paste, okay, there it is, and I think I can move it. Okay. Okay, I cannot move it, but I'm going to copy it here. So it is written in the order. It prefers writing things in ascending order, but we need to write it in descending order. So that is 8r cubed plus 22x r squared minus 24r plus 9. Okay, and what the thing is, I need to write everything else on the other side, only r to the 4th, the highest degree term. So this with 8r cubed minus 2r squared plus 24r. So don't forget to swap the signs. And now I know that I can replace the powers of r by an's, and as the power go down, the indices also go down. So we start with an, we have a times an. This is one less, so n minus 1 minus 22 an minus 2 plus 24 an minus 3 minus 9 an minus 4. And that's the characteristic equation. Sorry, that's the recurrence relation of our given solution here. Okay, all right. And of course, I could also have calculated the initial conditions by just plugging inside this equation here. What is n equals 0, 1, 2? Is that enough? No, I need 4 initial conditions, so I should also do 3 here. But that's not necessary because I know it. There's no need to know the initial conditions because I know the whole thing. So remember, this is the problem backwards, right? Okay, so that's the homework.